Hello everybody, welcome to our second lesson, online lesson. And today we are going to talk about sum to product and product to sum formulas. As you remember, we have started with double angle and half angle formulas, which we also covered before the spring break. But today we will work on the same lesson, the second part of the lesson. That is another type of formulas that's called sum to product formulas, identities, or product to sum identities. So we would like to call them sum to product and product to sum for some reasons, because if you check all these formulas that we have here, the four formulas, we start with a plus. We have sine plus sine. Since we have a sum here and that's equal to a formula here, sine times cosine right over here, we call it product formula. So sum to product, that's the reason why. In the second one we have a minus, but minus can be considered as plus because in math actually we have two operations. One is multiplication, the other one is addition. Subtraction is under addition and division is under multiplication. So we can consider two, that's why we say sum to product. Here we can consider this as sum or difference is equal to a product of two trigonometric terms. And so on, so on. That's why we call it sum to product formulas here. So we will have only four. We will not have the tangent, cotangent, secant, or cosecant of them. It will be all about sine, 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 cosine, cosine with sine. These are the ones what we will have. So basically, if you have a sine A plus sine B form, that's the formula. If you have the sine A minus sine B form, that's the formula. If you have cosine A plus cosine B form, and if you have cosine A minus cosine B form, that will be the formula. That's the deal. So again, we don't have to memorize them, but we can use these formulas if it's asked about how to convert a given addition, subtraction to a multiplication form of the trigonometric identities. So let's get started with our first example type, and let's see what we can do. It says example 7. As I said, we are starting from the second part of the lesson 7-4. That's why, as you can see, we have the formulas here. I would like to call them as formula 1, formula 2, 3, and 4, as it will be easier to catch out which one is which one. So the first question says sine 2 theta minus sine 4 theta. So if we look at the formulas, we will just match what we are given with one of these four formulas. Since it is sine minus sine, as you can imagine, that's going to be a number 2, right? So where we can say A is like a 2 theta and B is like 4 theta, right? This. So it looks like the formula says it is equal to 2 cosine A plus B over 2 times sine A minus B over 2. So what we will do is just follow the formula, that's it. So it will be 2 cosine A plus B over 2. So A is 2 theta, B is 4 theta over 2. It's the theta, not 2nd, like this one. And sine A minus B. So basically we will have a 2 theta minus 4 theta over 2, like this one. And we will just simplify. You know, this is still 2 cosine. 2 theta plus 4 theta is 6 theta, divided by 2 is a 3 theta. And sine 2 theta minus 4 theta over 2 will give us a negative theta, as you can imagine, right? Like this one. So maybe if we finalize it, this negative for the sine negative theta can be carried in the very front, and it can look like a negative 2 cosine 3 theta times sine theta. One more time, we just carried the negative sign in the front that we can do for sine. Alright, so it looks like sine 2 theta minus sine 4 theta is equal to negative 2 times cosine 3 theta times sine theta. That's it. We just converted the sum formula to a product formula. Let's see a couple of more about this technique, the formulas. The new question, before that again, I should write a 1, 2, 3, 4 here for the formula types, and let's see which ones we can use. If you want to solve it, you just pause the video, try it, and check with the solution that I will write here. Question 43 says cosine 4x minus cosine 2x. So looks like we have cosine minus cosine, and that definitely goes to the fourth formula, right? So if you follow it, as you can imagine, a will be the 4x, b will be the 2x, right? So if we continue with this, it's gonna look like negative 2 sine a plus b over 2. So that's a 4x plus 2x over 2, like this one, and times sine a minus b. That is a 4x minus 2x over 2, like this one. We'll just simplify it, and that will be our answer. Negative 2 sine 4x plus 2x is 6x, that's a 3x. And sine 4x minus 2x is 2x, divided by 2 is just x. That's it. That's the end of the question. 443. Negative 2 times sine 3x times sine x. We used the fourth formula. Alright, let's continue with question 45. As you can see, this time it's not algebraic more, it's more arithmetic, that we have only numbers. Here you see we have a negative angle, so we have two ways that if you want to, you can just convert this negative 48 degree to a positive degree by just adding 360. That is fine. Or don't do that, just apply the formula directly, and if you want to get rid of the negative sign, just add 360 at the very end. That's also fine, so it's not a big deal. So question 45, I will go with the red one. If you can see, it's sine plus sine. That's definitely formula 1 here, right? So we can tell a is 25, b is negative 48. Let's just put on top again. A is 25, b is negative 48. Follow the formula. Formula says 2 sine a plus b over 2. So 25 plus negative 48 over 2. That's what we have for the first part. And it says cosine a minus b over 2. A is 25, b is negative 48, so negative 48 over 2 is what we should have here. We'll just do the math, and that's it. 2 sine, if you add 25 to negative 48, that's negative 23, should be negative 23 over 2, like this one. And the other part, if you subtract negative from negative, that is, as you can see, that's a 53, 73, positive 73 over 2. So that's it. We have 2 sine negative 23 over 2 times cosine 73 over 2, which is cool. We can just leave it like that. I know we have fractional angles, that's alright. That's not the point. It's all about how to apply the formula. That's it. So this will be the answer for 45. Alright, so let's look at question 48 for the last. And I will erase this part. Make sure you're writing this all down, taking notes. That's gonna help you. And we will move on. Okay, so question 48. You see we have sine 9x minus sine 3x. That's definitely formula 2. So it's gonna look like this. Question 48. If you would like to rewrite sine 9x minus sine 3x, the difference of the trigonometric ratios, as the multiplication, that will go 2 cosine. As you can see, a is the 9x, b is the 3x, so that's going to be 9x plus 3x over 2 times sine 9x minus 3x over 2. We use the second formula. 9x plus 3x over 2, 9x minus 3x over 2, which will yield to 2 cosine 6x times sine 3x. That's it. So this is how we can use the sum to product formulas. That's how it is. Alright. Let's move on to the second part. This time we are doing the opposite formulas, like inverse. Product to sum formulas. We had the sum to product, now product to sum. As you can see, we will have a multiplication this time. Cosine times cosine, and we'll convert it to this addition or subtraction of the angles. So it looks like cosine A times cosine B is equal to 1 over 2. This time we'll have coefficients as 1 over 2 here in the front. And cosine A plus B plus cosine A minus B. So the important thing that you should be looking at here, we have brackets here. That means the 1 over 2, the coefficient will affect everything inside. So make sure you have this cosine A plus B plus cosine A minus B together in the very first formula. And same thing for the others, as you can see here. Sine A times sine B is this. Sine A times cosine B here. Cosine A times sine B is here. So again, we don't have to memorize the formulas. We will just keep them here. And it will be on the next slides too, that you will see. Alright, so first question, 4 times cosine 75 times sine 25. Again, let's number them. 1, 2, 3, 4. We have the 4 formulas. Since we have 4 cosine 75 times sine 25, we will just look at this part. The 4 is irrelevant here in this case. We will just carry it on till the end and use it. But 4 has nothing to do with this. As you can imagine, that is cosine times sine. So if you look at the formulas, we have cosine times sine as in the fourth formula. Looks like we are using this formula, where we can say A is the 75, the angle, and B, clean that, let's rewrite it. A will be 75, B will be just 25, right, like this. Okay, so let's apply the formula. Formula says 1 over 2 times sine A plus B. So basically that's going to be sine 75 plus something wrong. 75 plus 25, like this one. Let me fix the pen, it's acting out again. Okay, so we said sine 75 plus 25, that's right, and minus sine A minus B. A is 75, B is 25, so there we go. Do not forget to have the 4 in the front. As I said, it is not part of the question, but we still have to carry it on. And if we go with the second step, 4 times 1 over 2 is just 2. It's gonna be sine 100, like this, minus sine 50. That's what we will have for the first question. So we use the product to sum formula. If we are gonna use the sum to product formula back again, which is sine A minus sine B type formula here, that should be the second formula in the first set. And if we do apply the formula back on this one, what we got here, it's gonna for sure go back to this what we have here. So as I said, these are opposite of each other. So you can verify the things, you can convert things from each other. The product formula can go to sum, and sum formula can go back to product. So that's the deal. Let's look at those 3 questions, and that's gonna be it for today. And if you look at 37, we have sine 58 and cosine 102. So it looks like formulas again here, 1, 2, 3, and 4, right? And the first one, sine and cosine, they multiply. So we have sine and cosine multiply in the third one. Sine times cosine. So we will just apply it. 2 is 2 from the formula, from the question. And from the formula we have another number, that's 1 over 2 this time. And it says sine A plus B. So basically we will have 58 plus 102 here. Plus sine A minus B. So that is 58 minus 102, like this one. Let's do the math. As you can see, they cancel. We don't have a coefficient at all. So it will be just as sine 58 plus 102. That is 160, I guess. And plus, if you subtract 102 from 58, that is a negative 44. Like this one, right? If we fix it a little bit more, if you don't want to the negative number, you can definitely carry the negative sign in the front of the sign. So it's going to be sine 44, negative sine 44. That will be it. That's the question 37. Let's continue with the question 39. I will continue with the blue color. So guess what formula we are using? Before saying that, actually you see how we have pi over 6 and pi over 3 here. These are the radian, as you can see. We can convert these to degrees just like that, 58 and 102 in the first question. Or just carry on without doing that. Continue with the pi's, doesn't matter at all. Which way you want, you can carry it on. Those doesn't matter. But here, let's not just convert them to the normal degrees. I will just carry on with the radians. Maybe that way we get used to the radians more, which you will see more in college if you take any math classes. So here is we have sine and cosine multiplied. So sine and cosine multiplied just like the first question. Looks like we are again using the third formula because sine and cosine multiplied. So again 2, which is from the question, and 1 over 2 from the formula. Right? So the question formula says sine A plus B, where A is pi over 6, B is pi over 3. Maybe we should have them here, A and B, just like A and B here. So we will say sine pi over 6 plus pi over 3 here, plus sine pi over 6 minus pi over 3, and that's it. They cancel again. If you add the pi over 6 onto pi over 3, that's definitely pi over 2. How do I know that? I made the denominator same. Pi over 6 plus 2 pi over 6, 3 pi over 6, pi over 2. Easy math, I just skip that. Plus, if you subtract the pi over 3 from pi over 6, looks like pen is not working again. That will be a negative pi over 6. Hold on. So that will be negative pi over 6 here. Remember I said we can put the negative sign in the front, so we can say this is sine pi over 2 minus sine pi over 6 is the answer. We can carry on after this. This is an answer. We can just stop here and say, hey, this is the answer. Or since we already know the chart, what is sine pi over 2 and sine pi over 6, we can definitely put them here. Remember the chart I gave you also in the Google Classroom. It says sine pi over 2 is 1 over there. And sine pi over 6, the other way to say sine 30 is 1 over 2. So the answer will be definitely 1 over 2. That's the answer for 39. Or we can even find the answer from the question by itself to verify is it actually 1 over 2. Just apply what is sine pi over 6, that's 1 over 2, times what is cosine pi over 3, that's also another 1 over 2. So looks like if we just see what's the answer from directly from the question, They will multiply and we will get another 1 over 2. So we just verified that is the answer is 1 over 2. Okay. Alright, let's finish with the last question. Question 41. And that's it. Let's go with the red color. Okay. Question 41. You see sine times sine, that's definitely formula 2. We are multiplying sine by another sine. So let's go with that formula. 6 is from the question. 1 over 2. If you follow the formula, it is now cosine a minus b. So it is just 4x minus 5x. Minus cosine a plus b. That's a 4x plus 5x. Like this one. Okay. So, that's a 3. And here we have a cosine negative x. If you subtract the 5x from the 4x, that's a cosine negative x. And 4x plus 5x is just 9x. So there we go. That's our answer. Oops, it's acting out again. Sorry for the pen, by the way, the marker. It's not working properly. But that's it. That's the answer. So 3 times cosine negative x minus cosine 9x will be our answer. Alright, so we covered the sum to product formulas and the product to sum formulas here, as you can see. We have questions on the Google Classroom about this lesson. The first part is about how to apply the sum to product, and the second part is a product to sum. That's it. That's what we will cover for this lesson. So make sure you finish the questions and submit it by next Sunday night. Take care, everybody. I will see you next class.